This is Dr. Carroll, and today's video is about the C++ Standard Template Library, an overview and more about containers. So first off, a little bit of history. In the 1990s, C++ was extended with a library of classes and function templates, which has become to be known as the Standard Template Library, or STL. The STL became standardized in 1999, and so after that, any compiler that claims to support standard C++ is going to support the STL. So before we get too much further in, let's talk about some terms. First off, a container. Now, a container has a special meaning when we talk about STL, and it holds another object, as you might have guessed. Another important term is iterator, and it's a way to cycle through contents of containers. And algorithms, well, you know what those are. So let's first start with a little bit of motivation. So the STL solves many standard data structures and algorithm problems. It makes solving many complex programs relatively easy. What it does is it allows you to focus more on the non-obvious part of it, and lets you just take care of the obvious part that's commonplace, and it allows you to focus more on the development time and reduces development time and maintain it and increases the maintainability of the code. It's a collection of useful classes for common data structures. It has the ability to store objects of any type because they're templated. And containers form the basis of the treatment for data structures. So let's talk about the STL containers. There's 12 in all, and there's 3 types of containers. There's a sequence containers, adapter containers, and associative containers. As a brief overview of those, sequence containers store by position in a linear order. That means that the items are stored, and that's important to them. That this one comes before that one, that there's a first and there's a second element in the container. An adapter container contains another container as its underlying storage structure. And associative, well, it stores elements by keys. That could be a name, social security number, M number, or a part number, for example. So let's drill down a little bit more into sequence containers. There's 5 sequence containers. We have a vector, list, a deck, and new to C++ 11 is array and forward list. So a vector is like an expandable array. You don't have to worry about how big it is, and it'll just take care of it for you. Wonderful. List is a doubly linked list. You never have to write a doubly linked list again, unless, of course, it's specified in the assignment. A deck is a double-ended queue, and the array is, well, an array class, but it gives you all the other features of the STL, a typical STL container. A forward list is a little bit more efficient than a list in that it's only a singly linked list. It only has that forward link in it. There's a number of adapter containers, a stack, a queue, and a priority queue. The stack, it provides a LIFO access, last in, first out. A queue provides FIFO access, first in, first out. And a priority queue returns an element with the highest priority. And I'll, in just a minute, cover these in a little bit more detail. There's 4 associate containers, set, multiset, map, and multimap. A set stores unique elements in an order, whereas a multiset stores elements in an order, but it allows for repeats. A map stores unique keys, and each of those keys has a respective value. And as you might have guessed, multimap stores key value pairs, but allows for duplicate keys. Let's talk about the vector container in a little bit more detail. So it, as mentioned just before, it is a sequence container, and you can think of it as an array class, but it's going to store elements of the same type, but it allows you to access them by index anywhere from 0 up to 1, less than the size of how many elements there are. But the beautiful thing is it grows and contracts dynamically at the end of the sequence. So you don't have to worry about that ever again. So here's a little example. First, you need to have a pound include vector so that it knows about that class. You're going, here for example is an instantiation of a scores variable that is, it's a vector, and each of the elements are a float. Remember, it's templated, and this is how we specify a template with the angle brackets here. And then this calls the constructor. So we're going to get 100 float scores. Here, in the next example, we're having a variable called passenger list. It's a vector, and it's templated with a type passenger, whatever that is. And again, this calls a constructor and says, hey, we want space for 20 passengers. As mentioned, you can treat vectors a lot like arrays. You can even use the bracket notation to get at a specific element and either assign to it or read from it. Let me talk now a little bit more about the STL list class. So it stores elements by position. You know about linked lists and how they work. And each element in the list has a pointer to its next one and a previous one, and also space to store that element. But with a list, if you want to access a specific element, you've got to traverse the list, just as you would expect. To say this differently, list is not a direct access structure. But it does have the advantage of being able to add and remove items efficiently at any position in this sequence, instead of just at the end, which is how vector is most efficient. But it pretty much has all the same functionality as a vector, except a capacity method, reserve method, at, and the square brackets operator. Another sequence container is the deck container. And yes, it's pronounced deck. And deck is an irregular acronym for double-ended queue. And again, just like the vector, it grows and contracts dynamically, and it also provides random access to all elements. But the way it's designed, its implementation, is that it's efficient at adding and removing elements from either the front or the back. And so if you're going to be adding elements to the front, it'd be much more efficient to use a deck than a vector. I'm not going to go into array and forward lists. I think you understand those well enough just from the brief description previously, which takes us to adaptive containers. These containers restrict how elements enter and leave a sequence. First of all, a stack. You've already learned about this before, hopefully. And it strictly allows access to one of the elements, and that's at the top of the sequence. So we can add them on by pushing them, and we can remove them by popping them. But please note, if you want to be able to get a copy of that, you need to call top before you call pop. Okay? Again, it's a LIFO, last in, first out. Similarly, a queue container allows you to access only at the front and the rear of the sequence, and items enter from the rear and exit from the front. And if you've ever been to the UK, that's what they refer to as a line. For example, if you're waiting for movie tickets or at the grocery store, because we all know that everyone gets in the back and exit the front, and There's no deviation from that. Well, at least in the STLQ container, that's not allowed. It's FIFO, first in, first out. That's just saying it differently. And again, there's a push. It adds an object to the queue, and a pop removes the front one. Again, if you want a copy of what that front one is, before you do pop, you need to do a front call to figure out what it is. The priority queue container is similar to a stack in a queue in that elements can enter the priority queue in any order, but the key difference is when you delete an operation, it removes the largest value in the container. For example, if you had a system that you wanted to filter, and it takes in all the elements, but it only releases them in priority order. So our last type of containers is associative containers. So the first one, that brings us to associative containers. The first one is the set container. It's a collection of unique values called keys. And what the class allows the programmer to do is determine whether a certain item is a member of the set and to insert and delete items very efficiently. Multi-set, as mentioned before, is similar to a set, but you can have duplicates. A map container implements a key value relationship. So a programmer can use a key to access the corresponding values. For example, if you had items keyed by a part number, then you could get that value, which could be an object, which could contain its name, its price, and, for example, the manufacturer. Similar to a map container, the multi-map container, but it allows for duplicates. That's it for the STL containers.